Welcome to aminacademy.com. In mathematics of quantum mechanics, let us discuss about complex numbers. Now, what is complex numbers? Now consider a quadratic equation. You know that quadratic equation is ax square plus bx plus c equal to 0. For this equation, the solution formula of the solution is x equal to minus b plus or minus root b square minus 4ac over 2a. We know this. By using the values of a, b, c, we can get the solution of this complex number. Now, in this, consider this equation. Let us solve. Solve x square plus 5x plus 15 equal to 0. This is some quadratic equation you have to solve. So over here, a equal to 1, b equal to 5, c equal to 15. Let us use the solution. X equal to minus b plus minus root b square minus 4ac over 2a. This is we apply the values abc. A equal to b equal to 5. So minus 5 plus minus root b square, that is 5 square minus 4. A is 1, c is 15 over 2a. Here minus 5 plus or minus 5 square is 25 minus 60. 4 into 15 is 50 by 2 into 1. Here x equal minus 5 plus or minus root of minus root of minus 35 by 2. Here root of minus 35 is not real because under the square root there is no minus. From this the complex number starts. Here therefore this minus, therefore square root of minus 35 is imaginary number. Now what is complex number? A complex number is a sum of a real number and imaginary number. Consider this a plus bi. That means here root of 35, root of minus 35 can be written as minus 1 into 35. Square root of minus 1 into square root of 35. Therefore, square root of minus 1 indicates imaginary I root of 35. So in generally complex number can be written as a plus bi. This is a real part. This is a imaginary part. Therefore, a complex number should contain imaginary parts, may be or may not be a real part. Together, it says complex number. Now, generally we express z equal a complex number equal z equal a plus bi. Then real part of z, re of z equals a, then imaginary part of z equal to b. So generally representing that z equal to a plus bi is a complex number, and that real part is, that is real is z equal to a, imaginary is z equal to b. Now already we discussed that complex number, that quadratic equation. Consider x square plus 5x plus 15 equal to 0. The solution x equal to, we got this minus 5 plus or minus root 35 by 2, minus 5 root of minus 35 over 2. This can be written as minus 5 plus or minus I into root of minus 35 by 2 by 2. This, therefore, this is the solution is a complex number. Consider that z equal minus 5 over 2 plus or minus I root of, here positive 35, because I is my square root of I is minus 1. Therefore, that is square root of minus 1 is I divided by 2. This is a real part. Therefore, you can say real part of z is minus 5 over 2. Imaginary part of this number is root of 35 over 2. Because I is a representation of imaginary number, so imaginary part is root of 35 by 2. Now, how to represent a complex number in a complex plan? Consider this xy plan. This is x positive, negative x, positive y, negative y. This is an imaginary axis. Imaginary axis. This is a real axis. Then this part represent, this area represent a complex plan. Now, for example, the complex number z equal 3 plus 4i. How to represent? Here 3 is a real axis. So 1, 2, 3. An imaginary part 1, 2, 3, 4. We'll give some space and write z equal 3 plus 4i. So this both, look, this here 3, so 4. This is that complex This is a complex number. This represents complex number z equal to 3 plus 4i. So far, we discussed very basic things about complex number, and we'll continuous videos. We'll do about the operations on complex number, which are useful in quantum mechanics. We have done. Please subscribe our YouTube channel. Now, complex numbers are essential in quantum mechanics because they provide the mathematical framework to describe wave functions which have both real and imaginary parts. These complex wave functions, such as those in the Schrödinger equation, cannot be split into purely real or imaginary components and still accurately describe quantum phenomena like superpositions and interference. The probabilistic nature of quantum mechanics arises from the norm squared of the wave function, which is always a real number. That is a psi square, psi day square equal to psi day square equal to psi into psi. Now we have done. Please subscribe our YouTube channel.